Hi, everyone. I'm Shokoofeh Hesari, and I'm a senior software QA engineer at Schlumberger. As most of you probably know, it's an oil service company, and we're working on multiple web-based application and desktop application. And in this talk, I'm going to walk you through of my experience of integrating one image comparison testing and integrating it into our daily build pipeline. But before I start, actually, I would like to ask how many of you have this kind of testing in your QA routines in your company? Thank you, Andreas. You're in our team. Well, cool, two. Well, two, I guess, can I say is just less than 1%, like, 10%? Well, it's a really important type of testing, but simply overlooked. But why? Before I start and explain the challenges and why it's really overlooked, I'm going to say what is my topic, what is the context I'm talking about, okay? So our system is a web-based safety critical system that delivers a well construction solution planning. And our element of interest is the wellbore schematic that semantically means something to the user. So we really can't risk shipping it with any possible visual bugs that rarely get unnoticed by the end user and breach their trust to the whole system, really, not just this element. So talking more about the element is based on a third-party component and is totally exposed to changes itself and our interface. So we're really aiming to identify these issues as early as possible, of course, with the least manual effort. So putting all these standalone image comparison tools beside, because it's not really efficient. So we're going to aim at using image processing libraries and integrating it into our test framework, and of course, into our daily build pipeline that is based on a continuous integration system. Approach. And of course, because we cannot afford any broken build pipeline, we're going to aim to have a stable test suite. Otherwise, we really cannot afford it. Just starting with the basic idea of image comparison. What is it? Is usually having a benchmark, mock-up as a benchmark, and comparing it to the actual image that is present in the website. And report the difference if there's any. Well, it sounds all simple, right? So what is the fuss all about? Why people trying to avoid it? Or I say, why the image comparison actually fails to deliver? So let's start with a few of them that people think and is a kind of excuse. Other words, what are the challenges to a stable test suite? People say it's a high chance of false positives. What they mean by that is that I have a benchmark, I have an actual image. Well, looks identical to me, right? Okay, I was really worried someone would say no. I was like, oh my God. And we ended up having this result as our first experience. Well, a bit of wondering, we ended up getting to this conclusion that a screen resolution that I'm developing the test with the one that actually executing the test have different screen resolution. It ends up having the browser, different browser size than image sizes. So I'm getting up with getting every pixel in the image different. That is not actually. Even after tackling this issue, we ended up having this one. Do you see any difference? Let's look a bit closer. Do you see this few pixel different? It really don't get noticed by the end user, and it's not really important. So it's a false positive. And the issue is called anti-aliasing. And before I kind of jump to other challenges, I'm going to just briefly explain this concept for the people that don't know about it. Anti-aliasing is a stair-stepping of edges when you diagonally put the pixel here. If you put the pixels beside each other, you really don't see the difference. But when you make it diagonally, you see these jaggies here. And what is anti-aliasing is smoothing out these edges with getting the average of the pixels at that boundary. And different machines, different graphic cards, using different anti-aliasing approaches. So you can end up having different values in one pixel, like here. But actually really don't get noticed by the end user. What are the other excuses people talking about? They say high maintenance effort, right? But what they really mean by that is that here I have a full screenshot, And they said we use time, data, header icons can be different, other elements in the page can be different, and it makes like the whole image comparison testing fail without giving me any valuable information. So the question is, are you using a correct test scoping? So if you have few elements of interest in this page, where you're not looking for just those two, right? I know it's not really straightforward. Getting the full screenshot, cropping the element out of it is really messy. It's not really a streamlined process. But why are we not looking for the solutions that recognize this CSS boundary and take the screenshot of those elements? So even though like having multiple tests. What's the other thing? Is that if the goal is like actually integrating these tests into our daily build pipeline, not only should work with the real headful. So as a QA, maybe I really want to see what kind of tests I'm developing, right? So think that like in the interaction with the browser, it's called real browser mode, right? But when I want to integrate it to the build pipeline and getting executed there without affecting getting affected by the post condition of the previous test and affecting the precondition of the next test, so I want to run it in the headless browser mode. It means getting executed in the background and it really doesn't get affected by kind of other tests, right? So let's start shaping up with the solution with addressing these two requirements. Getting element boundary and browser mode. Do we have any technology limit? Of course. The front end we're using is based on Angular. So we chose Protractor as end-to-end UI testing framework. We're looking for the solutions can get the integrated in this framework. I'm sorry, just for the people to know, the Protractor is a framework that can execute Angular and AngularJS application in a real browser and run your test as a real user would interact with the browser. So it's a front-end framework. So there are a few plugins in the market that can get integrated in this framework. Between these, we chose Protractor image comparison because it can address both of these our requirements that we have. Are we trading of any weakness? Yes. The plugin is based off the pixel-to-pixel comparison, and therefore is we getting stuck with the old classic problems of image comparison that we mentioned in the false positive slide, anti-aliasing, different screen resolution, like getting changed, like the browser moved slightly and stuff. Okay, how can we amend these weaknesses? Well, we can try. So anti-aliasing. We got lucky. The protractor we found that is using another plugin, resembles JS. I don't know if you heard about it. It's actually a really cool one. Is using a parameter to ignore this one for good. So we almost got this one for free, and we're so happy about it. But even after tackling this one, we ended up having this difference. So you remember from the false positive one, it's because of different screen resolution, right? So what we can do for this one? Well, we tried few, but the thing that worked, we got back to our own element, made it testable. We fixed the CSS element size to the benchmark image size. But maybe it's not really a solution for every company. Maybe you have a business requirement to make it floating or anything. So it's always not a solution. We just got lucky. Oh, sorry. OK. What are the second options? Well, you easily can use auto-scaling image methods. There are a few plugins existing in the market that they offer that one. And in my experience, I tried it myself. It's not that mature. So I totally recommend it. If you have to do it and you cannot get back to your own elements and make it testable, customize one for yourself. Implement it using the latest image scaling methods in the market. And is any other few tips and tricks to make your test even more stable? Yes. Use an image format with an acceptable compression method. In other words, don't use JPEG. JPEG is using a lossy, low compression method and brings this sort of inaccuracy in the compression results. So we skip the JPEG and we vote for PNG, and it works real well, actually. Choose a sensible threshold for pixel and color tolerance. Well, we got lucky. Elements how we are using is a grayscale, so I'm going to skip the whole discussion, kind of cheat and discussion about the color depths issues. So for the pixel, you don't want to go so high that don't get some kind of error that there's a small element of picture is missing. And you don't want to go so low because you end up getting so many false positives. So just experiment with it. Like remove the smallest part of your benchmark, for example, and find the error, right? And adjust that threshold to get that error. Thank you. And if you can just go for the headless comparison, it's much more stable, of course. But if you had to stuck with the real one, the only tip I can say is just don't interact with the screen, don't use the mouse, and don't run any application that interacts with the screen, because it's changing the anti-aliasing format or the result for the pixels. We ended up having a stable test suite. And when we want to integrate it, of course, as early as possible. So as our component was a JavaScript library that could be integrated into our component, we used front-end integration test suite that could be as early as possible. And I'm going to remind you why we were investing so much into reducing this number of false positives. We cannot really afford any broken build pipeline, right? We don't have time for it. And other tips, invest really on expressive reporting. So if your test is broken, then you know the difference. You don't it's going to manually logging into the test server is really messy, and it's really not a streamlined process. So report your actual and difference image. And I'm just going to wrap up. So for this sort of testing, it's like customization process is not really hard. It's really needed. So just you need to customize it to your own solution. So monitor the test in a feature branch until it gets stable. What do you have to do for it? Just you need to invest on the performing proper due diligence between existing solutions. And for that one, choose the right criteria to do that. Well, what is the browser mod you have to do? Is it like headless, anti-aliasing you need to address? You need to exclude, it's like few element of interest you have or not. And if the plugin should have adjustable threshold for your own context. And of course, you're trading up for some weaknesses that you have to amend, and invest on expressive experiment thresholding, defining meaningful precision, and invest on expressive reporting, so it makes the debugging much more efficient. So that was it, and thank you so much for attention. And you can reach me by my email or LinkedIn. Thank you.